It is because of me. I was not keeping well, so therefore we couldn't take the class. So let's start. So we have already talked about uh, evaluation of some kinds of integrals. Today we are going to talk about improper integrals. So we all are aware that an integral of this kind, whose we all are aware with this. Here a and b are finite, okay, and this function is continuous in a and b. That is, at every point, this function is continuous. Is it or not?
Yes,
We
sir.
are aware with this kind of thing. We call it proper integral or regular integral, whatever you want to call it. Okay. Now, but that what if that any of, or at least one of the conditions are violated? That is, that is A or B or both A and B are not finite. Okay. What if that in this kind in an integral, these limits A or B or both A and B are not finite, or or function is discontinuous at some point between A and B. Means it, that point could be A, that point could be B, or that point could be some other point C, which is in between A and B. Somewhere within this range, A and B, somewhere that point could be. At that point, this function is discontinuous. That is, it has, let us say, singularity. What does it have? Singularity. Singularity means that as that value approaches, the function goes to the infinity. It blows up. That we call as singularity. In very simple words, if I have to say that as some point approaches, the function goes to the infinity. Let me. So, is it clear to you all?
As
Yes, sir.
suppose
Yes, sir.
All right. So now, singularity means that suppose at this point, as this point approaches, just see at this point A and at this point B, here what is happening? This is going to infinity. So there is singularity here, or singularity here. Hmm? Is it clear?
Yes, sir.
So,
Yes, sir.
so we are talking about such kind of situation. Hmm? So at least one of the conditions have to be violated. If that is the case, then that integral is known as improper integral. What it is known as? It is known as improper integral. Let us say examples. Let us take one example. The first example I take, that this one. Okay? Or this one. All right? So
Sir.
this is, here you can see that A or B or both A and B are not finite, right? So this is an example of both of them. They are examples of improper integral. Okay? Let us take another example, that between this 0 and 1, dx by x. Once again, it is an improper integral. Why it is improper integral? Because 1 by x approaches to infinity as x goes to 0. You just see, as x goes to 0, it blows up. All right?
Yes, sir.
Fine. Another example, let us take. Just, just pay attention to the limits. Limits in this case and limits in this case. Okay? Just pay attention to that. Okay? Similarly, let us say 0 to 2 dx by root over 2 minus x. This is also an improper integral because 1 by root 2 minus x goes to infinity as x approaches to 2. Huh?
Sir.
Yes, sir.
Somewhere actually somebody's mic is on and I'm getting constant sound which is very irritating. Please switch off your mics. Right? Then next, minus 3 to 3 dx by x dx by x into 1 plus x. This is also an improper integral. Right? Why it is an improper integral? See, between minus 3 and 3, there are 2 points, 0 and minus 1. X equal to 0 and x equal to minus 1. Look at that, these 2 points. As as x is equal to 0, 1 by x, 1 plus x goes to
Infinity.
infinity. And when x is equal to minus 1, then also it goes to the infinity. Okay? So this is again an example of improper integral. Again an example of improper integral. I hope it is clear.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So now, if I look at this first example, this example. So this is known as improper integral of first type. This is known as improper integral of first type. Sorry, improper integral of first type. Hmm? And all these integrals are known as improper integral of second type. Okay, right? Now, what is the difference between these two? See, here in this kind, one of the limits or both of the limits are not finite. Is it clear?
Yes, sir.
Yes.
In this case, for example, let us say in this case, that's not the case. Okay.
Yes, sir.
However, however, at one point, this function is discontinuous. So in this case, function is discontinuous when x is going towards 0. Okay, when it is approaching 0. When in this case, when x is approaching 2, this function is going to blow
Two.
up. Okay, once again you have singularity here or discontinuity, right? Is it or not?
Yes,
You
sir.
have discontinuity, that is you have singularity here. It is going to infinity. Okay, in this case also, once again you see at 2 points, not one. In fact, at 2 points you are getting singularity. Okay, so here this kind of integral is known as improper integral of second type, where this function, so can I remove, where this function f is has singularity at some number c, which is between a and b. So that point could be a, that could, singularity could be at a, singularity could be at b, right? As we have seen in example 2 and 3, singularity in example 2, singularity was at x equal to a. Is it or not?
Yes, sir.
And in example number 3, singularity is at other extreme, point B. Okay, or it could be within this range somewhere. So, so such kind of improper integrals are known as improper integral of second type. Now, the thing is that these improper integrals can have can converge, that is they can give you a finite value, or they may not give you a finite value, right? They may diverge, they may converge, they may diverge. So if I want to evaluate an integral, I want to evaluate an integral, how can I do it? So first of all, I am going to apply this logic for the evaluation of improper integral of first type. Okay, integral of first type. Let us take case number 1. Okay, that let us say that function is bounded, that is it is continuous and integrable grable in some range this x is greater than a, okay, for all, right? Then the improper integral a to b, a to infinity, a to infinity f dx is defined as, how can we define, we can define it as limit x tending to infinity a to x. Now you just see that instead of this infinity I have put x over here, and I am saying that limit of this x is tending to infinity. Hmm? So I can define it like this, provided the integral exists. In other words, it converges, provided it converges. So that is how I can evaluate it. So I can write down more formally like this, the whole thing. Once again, I can write down that I have been given an integral like this. This is an improper integral. This can be written as limit some number x tending to infinity, and so the limit goes from a to x f. Okay, this is how I can define it. So now let us see an example of this that will make the things clear. यहाँ तक सबको समझ में आ गया?
Yes, sir.
Yes, sir.
All right. So now let us take an example. Example B is that this is what the improper integral of first type is, it or not? By definition, we have just
Yes.
seen,
Yes, sir.
right? So now this falls in the improper integral of first type. Okay, in that category it falls. Now I can write down it as limit x tending to infinity 0 to x dx by 1 plus x square. Can I write down it like this?
Yes, sir.
Now I can integrate it. Huh? So by doing so, what I have done, I can integrate it. So that integration will be tan inverse
X.
x. What is the limit?
0
0
to
to
X.
x. So limit x tending to infinity tan inverse x minus tan inverse 0. Right?
Yes, sir.
Huh? And so uh, this can be written as limit, if I put this limit, what I will get? This
Pi
will
by,
be
pi by 2, sir.
10 inverse infinity, that is pi by 2 minus 0, 10 inverse 0 is 0. So what is the value?
Pi by 2, sir.
Does it converge? Yes, it does. What is the value? Pi by 2. So that is the value of that improper integral. I hope it is clear.
Yes, sir.
Yes,
Okay.
sir.
Now let us take case number 2. That let us say that let the function be bounded and integrable. But now my x has changed from x to b for all x less than b. And I also say that this limit exists. Limit x tending to minus infinity for x to b exists. So I will define it as, I can write it as minus infinity to b can be written as limit x tends to minus infinity. So x to b f. So now I can write down it like this. I hope it is clear.
Yes, sir.
All right.
Yes, sir.
So once I have got this, let us take an example that how can we evaluate this kind of integral. Clear?
Yes, sir.
Okay. Shall I omit?
Yes, sir.
मिटा दो इसको.
Yes, sir.
Yes, sir.
So as an example, this is my improper integral. This is once again improper integral of first type. Is it or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. So how can I write down it like this? How can I write down? I can write down limit x tends to minus infinity x to 0 e to the power x dx, or limit x tends to minus infinity e to the power x x to 0, or limit x tends to minus infinity e to the power 0 minus e to the power x. Can I write down it like this?
Yes, sir.
And e to
Yes,
the
sir.
power minus infinity, that tends to 0. We all know.
Yes, sir.
Yes,
Huh?
sir.
Those who do not know, let us understand it like this. I can write down it as 1 by e to the power infinity. Can I write down it like this?
Yes, sir.
Okay. Now the Euler's number is, what is that? 2.7 something, right? So 1 by 2.7 multiplied by 1 by 2.7 multiplied by 1.257 and so on and so forth up to infinity. What will be the resultant multiplication?
Infinite.
Infinite होगा.
1 by infinite.
Yeah, right. That is, that will tends to approximately, not exactly zero तो नहीं होगा exactly, कुछ तो value होगी.
Approximately zero.
हाँ हाँ, जो भी होगा, लेकिन it will be approximately, मतलब means it will tends to negligible. Okay, so what is the then e to the power 0 is 1. So 1 minus 0, that is it okay? So this is what the value of this improper integral is. I hope it is clear.
Yes, sir.
Any questions?
No, sir.
All right. Let us take case number 3. Case number 3 is where both the limits are infinite. This is once again improper integral of first type. Okay, is it or not? So Let us say that C be some number. Let there be C some number. So I can write down the whole thing like this. Minus infinity to C and plus C to infinity. Can I write down it like this?
Yes, sir.
From the property
Yes,
of
sir.
with integrals? Or I can write down it like this: x1 to minus infinity, x to C, case 1 and case 2 we are imposing here, and plus x2 to infinity. So this will be C2 x2. Okay. What is the condition? That this should exist. So this is what we are going to now see, that what is the uh, example of this one. An example of this one we are going to check out. So minus infinity to plus infinity, x dx by 1 plus x to the power 4. This is the integral. Now this improper integral I have to solve. This is improper integral of first type, right? So let there is some C number is there. So I can write down it as minus infinity to C x by 1 plus x to the power 4 dx plus C to infinity x by 1 plus x to the power 4 dx. Or I can write down limit x1 tending to minus infinity x1 to C x by 1 plus x to the power 4 dx plus limit x2 goes to infinity C2 x2 x by 1 plus x to the power 4 dx. Is it okay? Or limit x1 tends to minus infinity, I can write down 1 by 2 d of x square 1 plus x square whole square plus limit x2 into it goes to infinity c2 x2, once again the same way I can write down. Is there any problem?
No,
If
sir.
I differentiate it, I'll get x dx only. Okay. If I differentiate this 1 by 2 dx square, I'll get x dx. Is it or not? So I
Yes,
can
sir.
write down. But
Yes, sir. Yes, sir.
by doing so, I have brought it in some form. By doing so, I have brought in some form which can be integrable. So I am now integrating it. So 1 by 2 limit x1 goes to minus infinity, and this will be
Tan inverse x square.
correct 10 inverse
X
x
square.
square. Okay, I just forgot to put limit over here, x1 to c. Okay, so x1 to c plus 1 by 2 limit x2 goes to infinity 10 inverse
X square.
square c2 x2. Okay.
Yes, sir.
And so this can be written as 1 by 2 limit x1 tends to minus infinity 10 inverse c square minus 10 inverse x1 square plus 1 by 2 limit x2 goes to infinity 10 inverse x2 square minus 10 inverse c square. All right.
Yes, sir.
Okay. So that is equal to 1 by 2. So I can write down it as 10 inverse t square minus pi by 2 by taking this limit,
Yes, sir.
plus 1 by 2 10 inverse, that means pi by 2,
5 by 2, sir.
pi by 2 minus
10
10
inverse.
inverse t square. Everything cancels out. The answer goes to 0. So the value of that improper integral is 0. So this is how we can evaluate this improper integral of first type. I hope it is clear to you all.
Yes, sir.
Okay.
Yes, sir.
We have seen different examples and it makes everything amply clear. मिटा दें इसको?
हाँ, sir.
Yes, sir.
हाँ सर
Yes, sir.
तो सबको समझ में आ गया यहाँ तक?
Yes, sir.
किसी को कुछ पूछना है? किसी को कुछ पूछना है? किसी को कुछ पूछना है? Does
नो
any-
सर
No, sir.
नो सर
Okay.
समझ
No,
में
sir.
आ गया सर
Okay. So अब हम बात करते हैं that how we are going to evaluate improper integral of second type. So we take case number 1. The case number 1 is that let us say that if A is the point of discontinuity. Okay, that is singularity of function f. Okay, then the improper integral, this is improper integral, is defined as, we can define this thing as that a to b, this can be defined as, we put some limit where epsilon goes to 0. When I put plus, it means it is on the higher side. Okay, right? Infinitesimally small. So a plus something. A plus something means infinitesimally small. आपने ये बात लिमिट्स में पढ़ी होगी. When we talk about continuity of a function,
Yes, sir.
then right hand limit and left hand limit. So whether we are going in the backward direction or in the left hand side, or we are going in the right hand side. So here we are going towards the right hand side, slightly more than that. And how much slightly? That is infinitesimally, small slightly. So a plus epsilon to b, b is the upper limit, right? This is not the point of discontinuity. The point of discontinuity is a. So I define this improper integral like this. I hope it is clear to you all.
Yes, sir.
All right. We can understand it with an example. Anywhere you couldn't understand anything, you can definitely ask. Okay. So now let us take an example. Example is this one. Okay, I want to evaluate this. Here you just see that as x goes to 0, 1 by root x goes towards infinity. So there is singularity at x equal to a. As x approaches a, the function shoots up. All right? Is it or not?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So, and just look at these values. That is not infinite, right? Is it or not?
Yes,
Sir.
sir.
Yes, sir.
Okay, so it means this is improper integral of second kind.
Second type.
Second type. Right. So now I want to actually solve it. So by definition, I go ahead. So limit epsilon tends to 0. That is 0 plus this epsilon to 4 dx by root over x. Or limit epsilon tends to 0, epsilon to acha. So what can I write down? What is the what will be the integration?
2 root x, sir.
2 root x epsilon to 4. That is what the limit is.
Yes, sir.
Is it or not? And
Yes, sir.
so limit epsilon. So this one will be 2 root 4 minus 2 root epsilon. Okay. This is infinitesimally small. So it means this is ignored in comparison to the first term. The contribution of first term is so much that contribution of second term doesn't carry any meaning. It is negligibly small. Okay. It is something like that dropping grain of salt in sea water.
Lake of water.
Oh yeah, bucket of water or lake of in lake water, whatever it is. So is it going to change the salinity of that?
No,
No,
sir.
sir.
Of course not. Okay, so it means that it is ignorable. Okay, we ignore it. What is the value then?
4.
4. So that is what the value of this particular improper integral. I hope it is clear.
Yes, sir.
Yes, sir.
Okay, now we go to the other extreme and we take that case. यहां तक सबको समझ में आ गया?
Yes,
Yes.
sir.
Yes, sir.
So the case 2. What is case 2? That if let us say B is the point of singularity. What is continuity? For a given function f. Then our improper integral is defined as a to b. This is that. Now you just see that earlier we were talking about a point. Now we are talking about where it is blowing up, B. So what we are confining ourselves slightly below B. That is
B minus
B
epsilon.
minus epsilon. I hope this is clear. So that is what I can write down. This epsilon is tending to 0, not exactly 0, so very, very close to B. This is very, very close to B, but not greater than B. It is below B. I hope it is clear.
Yes, sir.
Yes,
All
sir.
right.
Yes, sir.
So let us take an example of that. So the example is dx by root over 2 minus x. The limit being 1 to 2. Okay. Now you just see when x is tending to 2, this is going to infinity. So where is the singularity? At the higher end. At the upper limit, singularity exists. That is, the function is discontinuous. Is it or not?
Yes, sir.
Yes, sir.
All right. So now, in order to solve, let us use this. So limit epsilon tends to 0. A is 1. So 2 minus epsilon dx by root over 2 minus x, or limit epsilon tends to 0. What is the integration of this one?
Two root 2 minus x, sir.
Huh?
2 root 2 minus x.
Minus 2. Is it this what you are saying?
Yes, sir.
Okay. So 1, 2 minus. So now I can write down limit. This goes to this minus 2 root 2 minus, so this can be written as and plus 2. Is it okay after putting the limits? Is it okay? In place of x, I put 2 minus 0,
Yes, sir.
that will be epsilon, and if I put x equal to 1, so that will be 2. Okay. So this is negligibly small.
Yes, sir.
So it means 2. Right?
Yes, sir.
Yes, sir.
All right. So I hope you understood
Yes, sir.
Yes, sir.
that in all the cases, physically what we are doing, we are not exactly reaching to that point, but we are reaching very, very close to that point. We are at the cliff, we are about to fall, but we are not falling. ठीक है, हम एक छज्जे पे खड़े हैं और उस छज्जे पर हम इतना कॉर्नर पर पहुंच गए हैं कि अब हम गिर सकते हैं कभी भी, पर हम गिर नहीं रहे। अब इसका थोड़ा सा भी मतलब फूंक भी मार देंगे तो हम गिर जाएंगे। Understood?
Yes,
So
sir.
that is the
Yes, sir.
strategy.
Yes, sir.
So in order to evaluate, that is the strategy, that we are confining ourselves to either we slightly move ahead, like for example in the first case we slightly moved ahead. A पर थे, A पर infinity था ना, A से थोड़ा हम infinitesimally small आगे बढ़ गए, right? So that is what the strategy we adopted. In this case, we adopted that we restricted ourselves. Just we couldn't reach B. Just we are very close to B. I hope it is clear.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
So, so now let us take case 3. Now here we are saying that let A and B both ends are points of singularity. I gave an example. Okay, both A and B, both the points are both the points are points of
Similarity.
Singularity.
singularity, that is discontinuity.
Discontinuity.
Isn't it?
Yes.
This is an example which I have shown over here. So, so this is what now in such case, let us take a point C somewhere. Somewhere we take a point C. And we define this improper integral like this. How do we define? We define that we goes to A to C and then C to
C to B.
Okay, that is, I can write down it as epsilon 1. I go from A plus epsilon 1 to C and plus limit epsilon 2 goes to
B minus epsilon.
B minus epsilon 2. Right? Provided both these integrals exist, or provided both the limits exist. So both the limits exist. Right? Let us take an example of this one. यहां तक समझ में आ गया?
Yes, sir.
Yes, sir. Yes, sir.
So let us take an example. This is the example. Now you just see that as x tends to 0, this tends to infinity. Okay, it also tends to infinity when x tends to 1. So here is singularity, here also is there is singularity, that is discontinuity exists at both these points. Okay,
Yes, sir.
all right. So we are going to solve this problem. So what we do, let us choose a point, arbitrary point C. That C could be any number. Okay, so I can write down it like this. Now that number could be, let us say we divide it in half. So 1 by 2 dx by root x 1 minus x plus 1 by 2 to 1 dx by root x 1 minus x. So we have chosen a point C, half. Can I write down it like this? Surely I can write down. Okay.
Yes,
Is it
sir.
or not?
Yes, sir.
Yes, sir.
Now limit epsilon 1 tends to 0, so 0 plus epsilon 1, slightly we are going towards the right hand, and 1 by 2 dx by, I can write down it as root over 1 by 2 square minus x minus 1 by 2 square. Okay, plus limit epsilon 2 then 1 by 2 to 1 minus epsilon 2 dx by root over 1 by 2 square minus x minus 1 by 2 square. Is it visible? The lower part? Visible?
Yes, sir.
So I can write down it like this. Is there any problem?
No, sir.
No, sir.
All right. Now I know that it can be integrated, this thing. If I integrate it, what I will get? Sine inverse x minus 1 by 2 by 1 by 2 epsilon 1 to half. Is it okay?
Yes, sir.
Sir.
Integration of this is this only.
Yes, sir.
Yes, sir.
ठीक है ना? Plus limit epsilon 2 once again sine inverse x minus half by half, and this will be 1 by 2 to 1 minus.
सर
हाँ बोलो
सर 1/2 भी तो बाहर रहेगा.
कौन सा?
1/a sin इनवर्स x by a होता है ना सर,
हाँ
तो हाफ बाहर रहेगा ना सर.
कौन सा तो किया ना,
अ,
ये 1 by 2 लिखा है ना यहाँ पर, वो काय के लिए
sin
लिखा है?
इनवर्स x by a हो गया, लेकिन
हाँ
होता 1/a sin इनवर्स x by a होता है ना सर.
हम्म 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 हम्म,
तो 1/1/2 करेंगे तो 2 बाहर आ जाएगा ना.
हाँ
2 बाहर
2
आएगा
बार
ना.
आ जाए, 2 बार आएगा, सॉरी.
2 बाहर आएगा.
ठीक, इट्स ओके. सो फाइनली क्या रिजल्ट आएगा तो इसका? व्हाट विल बी द रिजल्ट?
सर sin इनवर्स 1/a आगे नहीं आता सर.
क्या होता है? रूट ओवर ए स्क्वायर माइनस एक्स स्क्वायर.
उसका होता है सर sin इनवर्स x
ए
by a.
स्क्वायर माइनस एक्स स्क्वायर को करो ना इंटीग्रेशन, तो x इक्वल टू ए साइन थीटा है, तो dx इज इक्वल टू ए cos थीटा डी थीटा. नाउ डू इट. तो ए से तो ये कैंसिल हो जाएगा, नहीं आएगा 2.
यस सर.
सही बोल रहे हैं. मैं डायरेक्ट कर रहा हूं विद योर विजडम. नहीं आएगा, ये तो ये कैंसिल हो रहा है यहाँ पर.
यस सर.
सो इट्स ओके. सो क्या आएगा तो ये, इसका आप फाइनल आंसर बताओ क्या आएगा? ठीक है,
सर
राइट. सो क्या हो जाएगा? Nobody could give me the answer. 1/2 तो ये तो 0 हो जाएगा, होगा ना ये 0,
Yes, sir.
और ये हो जाएगा माइनस साइन इनवर्स, ठीक है? हाँ नहीं सॉरी, ट्वाइस, ठीक है? इज इट ओके?
Yes, sir.
और प्लस क्या हो जाएगा, साइन इनवर्स, ये हो जाएगा 2 माइनस 2 एप्सिलॉन, मतलब 1 माइनस, इज इट ओके?
Yes, sir.
माइनस साइन 0 है, ठीक है? इज इट ओके?
Sir.
ठीक है ना भाई? सो ये क्या हो जाएगा, सो कुछ गलती किया है क्या मैंने?
Sir, 0, sir.
नो, इट वोंट बी 0.
0 minus pi plus pi minus.
I can write down it like this also. Just a minute. I can write down it like this also. Sine inverse 1 minus, can I write down it like this?
Sir, pi आएगा.
This thing can be written like this?
Yes, sir.
Okay. And plus limit sine inverse 1 minus twice of this thing. So answer will be pi,
Pi,
if I
sir.
am not mistaken, pi by 2 plus pi by 2.
Yes, sir.
Is it okay?
Yes, sir.
All right. So this is the integral, improper integral of second type. One more case is left that we will discuss in the next class. आज जो पढ़ाया समझ में आया?
Yes, sir.
Completely?
Yes, sir.
Yes, sir.
All right. Okay. So we'll meet tomorrow.
Thank you, sir.
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 Welcome.